Good evening, everyone. Thank you so much for joining us. Welcome to Sky Observers Hangout. My name is Michelle, and I am the Director of Public Observing at the Adler Planetarium in Chicago. And I have a friend joining me tonight, and that is...
Me. My name is Adriana, and I am the astronomy educator at the Adler. We've got some other friends with us behind the scenes tonight. Our YouTube chat moderator tonight is Sarah. Hello, Sarah. And answering questions in the chat is our astronomer friend, Geza. So if you see the Adler's name highlighted in yellow, that's Sarah. And when you see a name with a blue wrench next to it in the chat, that is Geza, helping us by answering your questions and comments. So if you've got them, ask. Please.
Yes, please do. Now, Sky Observers Hangout is a place for us to gather together to nerd out about the sky. Our goal is to give you practical tips that you can find useful about a lot of things related to sky observing. And if you want to just watch the show, that's perfectly fine. We would love to see your questions and comments and observations in the chat. So feel free to interact with us and with each other.
Yes, we love hearing from you. So to get the show started, tell us in the chat. I know a couple people have already done it, but if you haven't, tell us in the chat where you are tuning in from. And as an added bonus, tell us what color stars you've observed before in your night sky.
And now, while the Adler Planetarium's doors must remain closed for a while, we are doing our best to keep our virtual doors open by creating and sharing some out-of-this-world content for you. If you wouldn't mind, use the link that will be put into the chat to donate what you feel comfortable to contribute to our programming. Thank you so much for allowing us to keep sharing our universe with you.
Absolutely. And you can help us get more visibility for our shows by hitting subscribe for the Adler Planetarium's YouTube channel right below this video. If you like us, give us a thumbs up too. So let's go ahead and see where you guys are all tuning in from tonight. We have Julie from Frankfort, Illinois. Hello. Teal from Columbus, Ohio. Oh, hey. Sarah is from Columbus, Ohio. Or
close to Columbus, I believe. Yes.
Close to Columbus. Okay.
She'll tell us.
She'll tell us.
She is an Ohio State fan. I know
Excellent.
that.
Yeah. We have friends from Downers Grove. Bill from Boynton Beach, South Florida. I grew up close to there. Hi, Rue. Excellent. Thank you all for joining us tonight. It's always really exciting to see all of our friends joining us here and see some new names in the chat too.
Well, we are so glad everyone is here. So, Adriana, would you like to kick off our exciting, colorful topic this evening?
Okay.
It doesn't get any better than that. So, yeah, if you're hoping for great astronomy jokes, don't look to me. They're not good. So, anyway, go ahead.
Excellent. Sorry. So we're talking about star colors tonight. To get started, Michelle, why is this something that we might want to pay attention to as observers?
Well, the light that you are seeing and observing, this simple blue point of light or reddish point of light in the sky, it carries crucial information to your eyes and to astronomers' telescopes and instruments and things. But that has allowed us to learn so much more about the sky, about space, about everything in it than we could have otherwise. We can't travel to most of that stuff out there. 99 put a whole lot of 9% of the universe, and just about everything we know about what's out there, we know from the light that comes to us. And so that's pretty amazing from a human perspective.
Absolutely. So we are going to go ahead and begin here with our observer's perspective. What can you actually see in your sky? What are some of the star colors you might be able to observe this winter? So I'm going to go ahead and share my screen. Give me 1 second.
So Adriana's bringing up an awesome tool. If you've joined us for Sky Observers Hangout before, you've seen it before. If this is your first time, this may be your first time seeing this tool. So go ahead.
We know and love it. It is Stellarium. All right, so Sarah is going to share the link to Stellarium in the chat for those of you who haven't used it before. But it is a web-based tool that you can use to look at what's in your night sky. So I have it set to Chicago's night sky, but your night sky is probably pretty similar if you're living kind of nearby. My favorite places to observe star colors in the winter sky is Orion. And that is this constellation right here. I'm going to zoom in on it just a little bit. There we go. So we've talked about Orion before, and we've talked about some of the stars in it, but it's very exciting. It's an exciting place to observe star color because you get kind of two ends of the spectrum here. So I wanted to start with
literally. That's good. Anyway, sorry. Go ahead.
both ends of the spectrum. So we've got Betelgeuse right here in the top left. Go ahead and click it to point it out for you, is a red supergiant star. So when you're observing it in your night sky, it's going to have kind of an orangey red tinge to it. And then in the same constellation on the bottom right, the brightest star in this constellation, Rigel, is a blue supergiant star. So they are easy to compare to one another, and you can notice that difference between the two. And then the three stars, the bright stars of the belt right here, are also all blue stars. And Michelle is going to remind me of their names because I forgot.
They are Alnitak, which is the lower leftmost one. So if you click on that one, you'll see that.
Oh, look. Yep. Yes. Okay.
And then if you go to the middle one is Alnilam.
Alnilam.
And then
I tried.
There you go. Yep, you got it. And then Mintaka. That's the other one. So yeah, those are blue supergiant stars, and they're pretty cool to take a look at. But yeah, everybody knows Orion's belt. There you go. By the way, I apologize if I just butchered those names. They're fun to say, but if I didn't pronounce them correctly, you can put in the chat how to actually pronounce them correctly. So go ahead.
Excellent. So this is a great place to start with your observations. Michelle is going to take us through some other bright stars in your winter sky that you can see and compare to.
Yes, but wait, there's more. There are other bright stars with easily distinguishable colors in your winter night sky. And so if you take Orion's belt and you imagine drawing a line and you go down to the lower left, you are going to run into the brightest star in our Northern Hemisphere night sky. And that is the star Sirius. It is a bright white color. Might be a tinge of bluish white. It's a really bright star. And so usually a nice bright white color, especially when it gets a little higher up in the sky. If you take Orion's belt and you go up the other way, so you can use that to find lots of things. So you get to another star, that one right there. Yep, that is the star Aldebaran. And that is the eye of Taurus the bull. It's kind of an orangish red color. Then if you go upward, kind of diagonally, kind of Orion's shoulders are kind of sort of pointing in that direction, you can get to Castor and Pollux. Those are the two brightest stars in the constellation of Gemini, the twins. So Adrian's going to move a little bit. No, you're going to go a little bit off to the east. So
you can tell that it's live because I have gotten lost.
Nope. All
okay,
right, go
hold
down.
on. It just keeps spinning.
Yep, go down.
Thank you.
Keep going. Keep going.
Oh,
you'll get there. Just go all the way down to the ground.
I'm sorry. My mouse is being real weird.
This is called technical difficulties. Please stand by. So yeah, she was having some mouse troubles earlier. I mean, the computer mouse. So, oh my, you are now facing west. Do you want me to go to Stellarium? Do you want me to?
No.
Okay?
Yeah.
Okay. So anyway, I'm going to keep talking while she's going to the south. So we've got Orion. I'll do a quick review. Orion's belt, Betelgeuse, Rigel, his knee. All right. Orion's belt, down to the left, you've got Sirius. Up to the right, you have Aldebaran. And then up to the upper left from Orion, you've got Castor and Pollux. So Adrian, if you get, there you go. Got it. There's Castor.
Thank you.
And there's Pollux. Sometimes the Stellarium little box thing kind of gets in the way. So if that ever gets in the way, you can just click that little X and that gets rid of it. But that information that's in there is pretty cool. You can see a more subtle difference in color between the two brightest stars in the constellation Gemini. Castor is a white star and Pollux has kind of a yellow-orange tinge to it. Now for all these, just imagine pastels. We're not talking like vibrant. So we're talking pastel colors. And the other problem is in stellarium, you're not going to see the star colors in there. So if you're looking at this screen going, boy, that looks white to me, it's okay. It looks white to me too. But in the real sky, that's when you start comparing some of these stars, that's when you'll see some differences in those colors. All right.
Cool.
Okay. So
You're
I'm
gonna
going to
stop
come
sharing
back
my
to me.
screen?
There you
Yeah.
go. All right. So observing these stars with binoculars or a telescope will help you see their colors more easily. Now, why is that? You're gathering more light. You've got lenses that are bigger than your eyes, and so you're gathering more light from the star. So the color is easier to see when you make it brighter. So if you've got binoculars or small telescope, well, if you're in the Chicago area, don't go outside right now. It's snowing. But if you're someplace where it's clear out for you and you want to take those binoculars or your telescope out and take a look at these stars, they're up right now. So you can check these out. See if you can spot the differences in color for yourself. You can also take your binoculars or telescope out to check out binary star systems. We're talking pairs of stars, and sometimes these pairs have different colors. We love observing the star Albireo. It's a binary star system, or it's at least two stars that look close together. It's low in the western sky after sunset this time of year, but it's higher up in the fall. So you're gonna have to wait for the calendar to come around again to be able to see it, because you can see the distinct color difference between the blue star, which is the brighter one, and the gold colored one, which is the dimmer one. So you can use stellarium. This is your homework. You can dial up stellarium for yourself and figure out when the best time of year is to see Albireo where you are. All right.
Awesome.
So shall we go on to what the heck these colors of stars actually mean?
Yes. So we are seeing these different colors in the sky, in our stars. The question is why? So, what does it mean? The short answer is that different temperatures of stars will shine most brightly in different colors. So, to explain that, let's start with something a little bit more familiar. Michelle's going to pull up our slides here.
Go for it.
If you've seen white light through a prism, you understand that white light is made up of all of the colors of the rainbow combined. So your eye interprets the combination of all those colors coming from the same object as white. In the same way that white light can be broken up into a spectrum or a rainbow of the different colors that make it up, so can most kinds of light, starlight included. Different types of stars have different spectra. So let's take a look at two spectra of stars that Michelle was actually able to take with her telescope.
I'm so excited to show you guys this. We've been like geeking out about this for like a week. All right, go ahead. Sorry.
Yes. So these are two stars in the winter sky that Michelle was able to get a spectrum of. Starting with the top star, I wanted to ask you guys, which color or colors do you notice look more prominent in this star's spectrum? So the ones that look kind of like they're taking up more space, they're a little bit wider, a little bit brighter. It might help to compare one end of the spectrum, the blues, to the other end, to the reds and oranges. So in the top one, tell us what you guys think. Are the blues more prominent or the reds more prominent?
So while you are doing that, should I show these guys? Should we mention how we actually did this?
Yeah, go for it.
Cool. All right. So I think you guys can still see my video while I'm talking. So I used this telescope right here, which I've jazzed up with some Christmas lights this evening. This is actually part of our show tonight. So I'll move those out of the way temporarily. We're going to come back to those. But this is one of the telescopes that we use for Scopes in the City when we're able to be with you in person. This is one of the telescopes we take out. It's just a 6-inch reflector telescope. So the main mirror, 6 inches across, really portable telescope. And then I put in this eyepiece right here. This is a 25 millimeter eyepiece. All right. So I put it in right here. And there we go. Of course, you got to take the cover off the top. Oh, sorry, I forgot one thing, one important thing. That would be normally what we do to set this up. But I had one more interesting little gizmo, and that is a filter that you can attach to the eyepiece to show. Oh, I'm going to do this. I know I'm not supposed to do this right now, but check it out. Check it out. Check it out.
Cool.
Haha.
What does the
So
filter do?
the filter splits the light of whatever light comes in to its component colors. And so you attach it to the bottom of the eyepiece. Eyepieces have threads, and these filters have threads, and they normally are all the same size. So then you put that in, and then I grabbed my phone and I stuck it up to the eyepiece after I pointed the telescope at a bright star, and I took a picture. That's all
Very
this
cool.
was. It was really cool. Anyway,
So
go
it's
ahead.
just that filter.
That's it. That's all
Awesome.
it was.
So we've got some answers in the chat. I'm seeing most people are saying blue for that top star. And they are absolutely right. That brighter blue, that blue is a little bit more prominent there. So this star in the sky appears to us as a combination of all of those colors, more prominent blues, some green and yellow light, and a smaller bit of redder light. So what color do you think that star appears in the sky, my friends? It's blue. Yeah, exactly. That's a blue star. That's actually one of the stars that we talked about before. What was this one, Michelle? Was it Mintaka?
This was Alnitak.
Oh, it's Alnitak. Thank you. Yeah, it's one of our blue stars. So you can actually tell from the spectrum that it is a blue star. And then on the bottom, you might notice that spectrum looks a little bit different compared to the top, right? So if you guys had to guess what colors do you think are more prominent there? What color star do you think we're seeing the spectrum for? I'm going to give people a second to
So while the wheels are turning, same exact thing for this one. I pointed the same combo at a different star, stuck my phone up to the eyepiece, and snapped a picture. I just snapped several because my phone wants to keep readjusting focus, and it's really hard to keep it from doing that.
Right.
But yeah, that's all it was. Simple.
Yeah. And people have correctly guessed it is a red star. So you guys can actually tell the difference from the spectrum. That star is Betelgeuse, right, Michelle?
Yes. Should I switch you want me to go on to the next slide?
Yes, I think it's the answers.
It is. It is. And so that was so exciting to actually see the difference in these stars. It was amazing that we could actually tell the difference from something as simple as an eyepiece filter and my phone. And that's really all that was. So, so to summarize, the color that your eyes see coming from a star is based on the spectrum of light, the spread of light you get from that star. Some stars emit more on the bluer end of the spectrum. Some stars emit more on the redder end of the spectrum. And some stars, like our sun, emit somewhere more in the middle. All right. So the combination of all those colors of light on the spectrum, some of which you're getting more of and some you're getting less of, makes up the color of the star that you see.
Yeah. So then a next question you might have is, what makes stars emit more light in one part of their spectrum versus another part of their spectrum? And that the answer to that is their temperatures. So hotter stars emit more bluer light, while cooler stars emit more red light. Other colors of star, yellow, white, and orange, are somewhere in between in temperature. So our astronomer in the chat, our very own Geza, helped us show this by plotting the temperature of stars in degrees Kelvin. So those numbers that you're seeing are the temperatures in degrees Kelvin of the stars, and he plotted it with the color of the star. So you can see as the temperatures go up, the stars get bluer and bluer, and the lower temperature stars are redder. So we can connect that pretty directly to our observations in the winter sky. Those redder stars that you see, like Betelgeuse and Aldebaran, aren't as hot as the bluer, brighter stars that you see, like Rigel. I think it's really neat that we're able to learn something about the temperature of stars that are light years away just by looking at them with our eyes.
Yeah,
so,
totally.
Yeah, so related to that, one of my favorite questions that I've gotten from guests at the Adler, and that I've seen a couple of times today in the chat already, why aren't there any green or purple stars? So you can see on this graph too, all of the stars are going to be somewhere between red, orange, yellow, white, or blue. Why aren't there any green or purple stars, Michelle?
Because green is closer to the middle of the spectrum. Stars that emit a lot of green light will also emit a fair bit of red, orange, yellow, and blue. When all these colors of light are combined together, your eyes will see white light. Even if the star emits more green light, than any other color. That's why most stars look white to us. So when you do see color, those stars are further along the hotter or cooler ends of the spectrum. Now, what about purple stars? Why don't we see those? Wouldn't that be cool? We don't see those. This one is a little bit more about our eyes than anything else. There are stars that emit a lot of light on the violet end of the spectrum, but they also emit a lot of blue. Our eyes are just much more sensitive to blue light than violet light, so they still appear blue to us.
Very cool.
Really cool. Yeah. So, shall we see if there's any questions we need to check on real quick?
Yes, I think Geza has been pretty on top of them.
He usually
Somebody asked,
is.
have you ever seen a green star? No, I wish.
No.
Green is my favorite color, and if they existed, I would be so excited to see one.
I mean, Adriana is the standard bearer of the two of us to want to see a green star, and unfortunately, we can't show her a green star. There just aren't any. So
tragic. I'm disappointed too.
Yeah, our sun emits in like the yellow-green part of the spectrum, but it is definitely not green to us. So, all right, shall we go on? Are we good?
Yes, I think so.
All right, and thanks, Geza. And this is probably the show that is most appropriate to give him his full nickname, which is
Stargazer.
Thank you. All right. So what I think is most interesting about a spectrum is that it can be used to discern a surprising amount of information. The colors of light that we see and don't see, and the amount of light we get in those different colors can help us figure out a whole lot of stuff about space. The temperatures of stars, what elements stars and other celestial objects are made of, and in what quantities, and if and how fast something might be moving toward or away from us. Those spectra are responsible for a lot of modern astrophysics and our understanding of space. Now, this practice of measuring a spectrum and gleaning information about the object you're looking at based on how it interacts with the light came to be known as spectroscopy. This branch of science was incredibly important in the development of modern astrophysics. Now, two scientists in particular, William and Margaret Huggins, compiled an atlas of stellar and nebular spectra. Spectra of stars and spectra of gas clouds and other things, fuzzy things out there in space. Their work made them pioneers of spectroscopy. All right, so shall I share the screen here?
Absolutely.
All right, go ahead. Whoops. All right,
so
go
we're
ahead.
going to see two spectra come up here from a talk that William Huggins gave. It was called On Results of Spectrum Analysis Applied to the Heavenly Bodies. So it was a talk that he gave before the British Association on August 24th, 1866. So they show these dark lines in the spectra of Betelgeuse and Aldebaran. So two of the stars that we've actually talked about tonight. Those dark lines that you see are called absorption lines, and they help scientists figure out the composition of stars and other celestial objects. Here, the spectra of these two stars are compared to the sun. So what was special about the work of William and Margaret Huggins? Well, William Huggins and W.A. Miller together created an instrument that made getting stellar spectra easier, and they observed these spectra in comparison to the spectrum of the sun. They use the spectra also to learn what elements stars were made of. You can switch the slide, Michelle. At a time when nebulae were still not well understood because they were faint and difficult to see, Huggins also was able to get spectra of many things that people thought were nebulae, eventually concluding that some of them were actually fuzzy-looking groups of stars, so galaxies.
Yeah. That's pretty awesome. Now, Huggins was also the first person to determine using a spectrum of Sirius, one of those other stars we talked about, that shifts in a spectrum could occur when a star moves toward or away from us, and that the speed of the object could be determined using the spectrum. Those measurements were a bit inconsistent, he concluded that Sirius was moving 50 kilometers per second away from the Earth. He was a little off. Modern measurements show Sirius to be moving 5.5 kilometers toward the Earth in the general direction. Don't worry, we're not going to run into Sirius. Don't worry. Sometimes scientists make mistakes, but it was still an incredible achievement. Now, while Margaret Huggins was undoubtedly an important participant in a lot of this research and discovery, she's often not front and center in the stories, but we know now that her role was just as important. Her knowledge of photography and interest in spectroscopy helped the team begin photographing spectra, and records indicate that she played an important role in more of their work. And I have to admit, until Adriana wrote up this script, I truly had never heard of Margaret Huggins before. So I am very thankful that you included her in this show, because I bet she's brand new to not just me, but probably several folks out there in our audience. Pretty awesome.
Yeah, it was very cool to learn a little bit more about her. So we do have a couple of questions, Michelle.
Yes.
Is it true Betelgeuse may be in pre-supernova stage?
Well, Betelgeuse will explode. It will go supernova sometime in the next 0 to million years ish. Um, is it pre-supernova? We don't know. It did get dimmer last year. It released a bunch of material that became a dusty cloud that kind of obscured part of the view of it, and so it did look dimmer, and everybody got really excited because they thought, oh my God, Betelgeuse is going to explode. It didn't. It went, the gas cloud or the dust dispersed, and we can see it again. It's just fine. So hard to say. We can't put a pinpoint time clock on when exactly it's going to explode. I bet Geza has some opinions on that as well. So I'd be interested in see what he puts in the chat on that one too. We have another
Fair.
one.
Yeah. Jeff also asks, what's the upper limit for temperature of a star? How hot does it get?
Ooh, gosh. Well, eventually they do get too hot. They just can't hold themselves together. Geza's gonna have to correct me. I
Geza
want to
will help
say,
us out.
yeah, some of the highest temperature stars are like what, 40,000 Kelvin at the surface. I mean, we're talking in the tens of thousands of degrees, in the several tens of thousands of degrees. Our sun, for example, is at about 10 or 11,000 degrees Fahrenheit at the surface, and so we're talking several tens of thousands more. And so that's kind of getting up into your upper range there. Let me guess. Is that our friend, our buddy Jeff Greenspan? Is that my buddy Jeff?
Yes, Geza
Hi.
has told us the hottest main sequence stars are somewhere on the order of 40 to 50,000 Kelvin.
There we go. I did remember it correctly. Yay.
That
All right.
is too hot.
That is extraordinarily hot. Yes. Yes.
How hot? Too hot. Okay.
Too hot. Right. All right.
Excellent.
Any others?
I think that is all I'm seeing for now.
All righty.
So let's go ahead and move
I
on.
get to share my screen here again. We get to go back to these awesome spectra pictures. So, okay,
Lovely.
go ahead.
So luckily in the modern day, we don't need particularly special tools to explore our own world through spectra. It's as simple as getting what we call a diffraction grating, which is just like a little film that helps you actually see the spectra from something that you're looking at through it. So Michelle, you told us a little bit more about how you got these spectra. I was wondering, for people who don't have telescope or binoculars but still want to try this out in some way, what might they be able to do?
Yeah, so you can get diffraction grating film. And so it's not terribly expensive. It's actually pretty cheap because you only need like a little bit, and you can get it in a sheet or a roll or a larger amount. So Sarah is going to put the link. I know we're going to probably say it a couple times, but the link to a company we have used. We are not necessarily endorsing this company. It's just a place that we've gotten diffraction grating film from before. You can get it in a variety of places. This particular company is called Educational Innovations, but again, there are many that you can get this from, and it's as simple as, if you want to borrow a pair of binoculars, or if you've got access to a telescope, you can put this diffraction grating into a card, For example, this card right here has just some copy machine transparency film, and you put the diffraction grating in the middle just to keep the oils from your hands off of it. That's all. And this will split the light up into component colors. You can give this a try. Hold this over the eyepiece or the binocular eyepieces, and you can give that a whirl. Am I forgetting
cool.
something important? I hope I'm not forgetting something important.
You are not.
Excellent.
We can also use that film to take a look at some other stuff, some other kinds of light, not just stuff like stars, not just stuff in the sky, but you can take a look at lots of stuff through that and see what the component colors or component kinds of light are that make it up. Right, Michelle?
Right. You want me to do my demo?
Yes.
Awesome. We've been looking forward to this.
Show us what it's like through a diffraction grating.
All right. Because through the magic of technology, we can take this diffraction grating and I can put it over the camera in my laptop. So I'm going to tape it so that it doesn't fall off. There we go. And
very cool. A spectrum. What's that a spectrum of, Michelle?
That is the spectrum of my dining room lights. that is, those are LEDs. So yeah, there's dining room lights there. Isn't that awesome? So cool. I literally just, you saw it. I just stuck the diffraction grating over the camera and the light is coming in. The diffraction grating is made of plastic that has a lot of lines per inch etched into it, and that acts like a prism, which I happen to have one of those here too. It acts like a prism that splits the light up into its component colors. So you can use this.
Oh, Michelle, can you go ahead and turn off the slides so that people can see a little bit better?
Yes. So turn off the, oh, sorry. I was still sharing my slides. Sorry.
Perfect. Thank you, Sarah.
Sorry. We get so excited we forget what we're doing sometimes, or that's probably just me. So there you go. You can see off to the side, like right here. You can see that that's the spectrum of the LED lights there. All right.
Very cool.
Yeah.
So we also have so you can take out a diffraction grating. You can use it to compare basically any of the lights or light bulbs in your house. Different kinds of light bulbs are going to appear differently. So incandescent bulbs, sodium bulbs, LEDs will all have different spectra. Michelle also took some pictures of Christmas lights. Oh, you can take them out now. Very cool.
I'm going to show the Christmas lights now because I do have a picture of them, but I'll show the picture in just a second. I just want to make sure that I am showing up well. So give me a second. I want to see. So there we go. There's the Christmas lights. And I'll bet you lots of people, you go, oh yeah, my kid, my grandkid, my cousin, whatever, has special like novelty glasses that make lights look like fireworks and whatever. That's basically what this is. It's basically diffraction grating. And so you can split the light up into its component colors. But we've got different colors here. So because this is kind of a jumble, I took pictures of individual lights so you can see the spectrum. Should I bring those up? Would you like me to bring those up? All right, give me a second. I want to hang these back up. All right, there we go. Okay.
John says that looks like one of Steve Cosgrove's jackets.
Of course it does.
It does. Our friend Steve Cosgrove always has light up jackets. They're very cool.
All right, let me go to the picture. So there's the picture of all of them, but again, it's kind of a jumble. So here are the individual ones. And forgive me, I need to keep an eye on the fact that there's a cat right here wanting to eat the Christmas lights. And so I'm keeping an eye on making sure that I can handle all of this. But I had to cover up all the rest of the lights to take these pictures. I literally just put the diffraction grating in front of my phone. All right, and you can do this for any light, not just these. If you go outside, the street light, the lights in your house. And so I had to cover them up so I didn't get the interference from the rest. So you can see the red light on the left, yellow light, and take a look at those spectra. They look surprisingly different. You can see hardly any green in the red light spectrum, right? And Here's the green spectrum and the blue.
Yeah, they're very
Pretty
much
cool. Yeah.
different.
Yeah. And you
I
can
think
see the red. Go ahead.
the purple one's my favorite.
Look at that.
Yeah, so they did manage to get like a purple looking Christmas light, but because our eyes are not super sensitive to violet, most of the purple that we see in our day to day is a combination of red and blue light that our eyes interpret as purple.
Forgive
So
me
you can
just
see that in the
one.
spectrum here. Yeah.
Forgive me just 1 second. I need to disengage a cat from the Christmas strand. So hold on. This is the first time you've gotten to see the cat on Sky Observers Hangout. He usually stays away.
Hello. Oh, he doesn't want to hang out with us. That's fine.
No, he wants to eat the Christmas lights. So that's a first for Sky Observers Hangout, is to see the pets. All right. So anyway, that was exciting. It was more exciting than I thought. Yeah, you can do all sorts of things with these diffraction gratings. Like I said, they're not expensive, and you can even do something that sounds a little daring, but if you still have those solar viewing glasses, those dark glasses, provided they were the correct ones from a past solar eclipse, and if you don't, just buy new ones. They're cheap. You can put the diffraction grating in with the solar viewing glasses, and you can see the spectrum of the sun. And just make sure it's the solar viewing glasses that are safe to use. And if you're not sure, just ask us and where you can get good solar viewing glasses, and we can let you know.
Absolutely. Reese says that this would be cool with fireworks outside, not in your dining room. Great clarification. I also would not like fireworks in my dining room, but I agree. It would make fireworks look really cool.
That would. He's back. So yes, and actually that would be really awesome, because they use different chemicals to make those firework colors. And so trying to get a picture of that through maybe a video with the diffraction grating held up to your camera, that would be pretty awesome.
It would be very cool.
Any other questions?
I think Geza has been on top of it. Does Adler, this is not related, but does Adler still have sheets from the Sloan Sky Survey?
Yes, we have at least one. And Geza can help me remember if we have a small or have a box of maybe 3 or 4 left. So the Sloan Digital Sky Survey was an effort to basically map different galaxies and other distant sky objects, and then they took these metal plates and drilled holes into them for the corresponding locations of those objects in a particular part of the sky. And then they put fiber optics and other things into those holes, and they were able to get the spectra of several hundred objects all at the same time. So we, yeah, we have at least a couple of those plates, those metal plates at the Adler.
I didn't know that that's what those were for.
Yes, yes. And I know you are thinking of one in particular in our executive lobby. That is a Sloan Digital Sky Survey plate. So
it's a table now.
I wasn't going to say it, but yes, it's a table.
Am I not supposed to? I think it's really cool.
No, it's fine. It's actually pretty cool. But we actually had a box somewhere of 3 or 4 more. I don't know.
Geza says 5 are in the collection and 1 is a table.
Got it. Okay. All right.
It is my favorite table.
There you go. There you go. It's a very unique astronomical table. So, all right.
Excellent. Oh, we have one person asking, where can I get a good telescope? So I do want to let you know we have a video specifically about beginner telescopes and choosing your first telescope. I think it's just Sky Observers Hangout, how to choose a telescope, right?
Yep.
Yeah. So there's a bunch more information about that. It's not a super easy question to answer very quickly, because what kind of telescope you get is going to depend on your needs, your budget, your, how you plan to get around, what you want to use it for, where you live. So check out that video, and that'll help you get answers to those questions and make a decision on that.
Yep.
Cool. All right.
Any other questions?
I think, oh, thank you so much. Sarah posted the video link. So that can help you and anybody else who's interested in learning more about getting their first telescope. Yeah.
Yeah, we get that question all year long, but especially right before the holidays when people are thinking about gift giving to other people. And so we did that one in November. So it was the November 9th Sky Observers Hangout. So check that out. That features several of our Adler Planetarium telescope volunteers as well, giving some of their thoughts and ideas on the many different kinds of telescopes that we all have. So yeah.
Absolutely. All right.
Anything else before we wrap up?
I think those are all of our questions tonight. Great. Well, we hope that you guys had fun with us. And that next time you look up at the stars, you'll be paying attention to the colors that you see in your sky, and you'll know exactly what they mean now. So be sure to send us your photos and your observations via our social media feeds using the hashtag #lookup. And thank you so much for joining us and supporting our programming. We love sharing this time with you.
Absolutely. And just remember, star colors, more like pastels, not your vibrant Christmas-like colors right here. So give that a whirl. We would love to know if you actually saw any of that in the sky. And we'd love to know, how did we do? We'd love to get some feedback from you. Sarah, in just a second, is going to link a feedback survey in the chat, and it will only take a very short time to fill it out. It's mostly clicking with a little bit of typing. And if you filled it out before, please feel free to do it again, because we keep track of our improvements. We go back to it many times to see how we're doing. And so it will help us make our future shows even better. And you can send us suggestions for future show topics as well. And you will also get to it via a link in tonight's program description. So if you miss it from the chat for Sarah, it's in the regular program description, so you can find it there.
Absolutely. And our next show will be on February 8th at 7 p.m. Central Time. And we'll be talking about the zodiac constellations, when to find them in your sky, and their history. So some of these constellations are the oldest that we know of. So be sure to join us in 2 weeks, and don't forget to subscribe to our YouTube channel as well. Thank you for hanging out with us tonight, everyone. And please keep looking up. Good night.
Good night. Thank you.